as you can see, we already have our little triangle up there, so we are ready to start talking about it, I guess. What I'd like to do is construct another one exactly like it. We've already done that by side, 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 where all three sides of one triangle was equal to all three sides of the other, and that worked good. And we've done it with side, angle, and side, where the two sides and the angle in between are the same on both triangles, and that worked. The two triangles turned out perfectly. And then we had another one also, which was angle, side, angle, where, say, for example, this angle and this angle, the side in between the two angles is included, and that gave us a pair of congruent triangles. And we were able to show that angle, angle, and side would end up being the same as angle, side, angle, because if two angles of the triangle are the same, the other angle must also match. So that worked out okay. But we didn't try to make a construction with that method. Alright, let's see here now. I wonder what would happen if we tried to do this angle here, and this side, and we could maybe have something called side, side, and angle, and let's see if that would work. That's the question mark. Alright, let's see what we can do with it. Let's get ourselves a construction line and as a place to start, and let's go right over here. I think this would be a good spot right about here. And we'll run our first line across here, so, and we'll pick a place to start on the line, and take our trusty compass and measure the distance from A to B. There we go. A to B, right about there. Come down here and mark it off. And I have here A prime and B prime over here. And now I want to copy that angle there. And I'll have this angle, this side, and then we'll go to get that side in just a minute. Let's see what happens. We're going to swing the arc across the angle. Remember, the central angle and the arc have the same measure. And here we go. And we'll measure out how much that arc is right here. That's pretty close. So if I run the angle up through here, this way, I'll have a copy of that angle. Like that. There we go. Now that's the angle here. And I want to get this side here and that side here. So I have side, side, and angle. Let's see here. I come up and measure this side now. And I'll come over here and swing that and see where it hits my line. Oh, it hits it right there. Well, that doesn't look very good. Those two triangles don't look at all alike, do they? But the distance from B prime to C prime is the same as it is from B to C. And the distance from B to A is the same as it is from B prime to A prime, and this angle is the same as that angle. So what I have here is side, side, and angle, but they don't look alike at all. So they are not congruent. What's happened is that I could have taken this angle, this distance here, and swung it all the way around over to here this way, and then extended it across here until I hit that arc. And then I could have connected it this way. And I think you'll see that these two triangles, the larger one here, let's just call this C double prime, A prime, B prime, C double prime would match. But because this one here exists and it also satisfies these conditions of side, side, and angle matching, and it doesn't work out that they are congruent, we cannot use this one. Not usable. And that's because all you need to do to prove something doesn't work is find one example where it doesn't work out. And therefore, it's just not going to work. All we need is one, and lo and behold, we've found one. This cannot be done. A lot of people will spell this one backwards and remember, uh-oh, this is the one that doesn't work.